Okay, so in this video I'm going to be going over the 5.1 to 5.3 quiz review. So the first one wants me to find the indicated nth root of a. Remember, this is writing it like this, with my n as my exponent and a as my, or n as my index, a as my part inside the radical. So this first one is going to be the cube root of 343, which is 7. On number 2, I'm going to do the same thing. I'm going to do the 6th root of 64. If I don't know this one, I can do the factor tree. I'm looking for groups of 6. I have 6 2s. This is 2. Because I'm finding an even root, I have 2 answers. On number 3, I'm taking the 5th root of negative 243. I can pull that negative out because it's odd. And the 5th root of 243 is, I can see these are divisible by 3, so that gives me 3 and 81, which is 9 and 9, 3 and 3. So this is just going to give me negative 3 for my answer there. On 4 through 6, I just want to simplify my expressions. The bottom number of the fraction exponent is the index for the radical. The top number is like a power. So on this one, it's really the square root of 36, and then I want to cube my answer. Square root of 36 is 6. 6 cubed is 216. On number 5, I want the 4th root of 16, and then I want to cube that. The 4th root of 16 is 2, and I want to cube that to get 8. On number 6, I want the 5th root of negative 32, and then I want to square that. The 5th root of negative 32 is negative 2. I want to remember to keep this in parentheses, and squaring that negative 2 is going to give me positive 4. On 7 through 9, I want to solve. So I first want to start off by dividing both sides by 5. I get x cubed equals 64. Then I want to take my cube root of both sides, which gets me 4. I could do the factor tree if I didn't know it. I have a bunch of 2's. On number 8, I want to get rid of my fraction, so I'm going to multiply both sides by 2. I get x plus 2 squared equals 128. And then I want to square root both sides. I get x plus 2 equals plus or minus the square root of 128. Here I'm going to take the factor tree of this one. So I get 2 and 64. I know 64 breaks up into 8 and 8. So that's my pair of numbers I can pull out. I have x plus 2 equals plus or minus 8 square root of 2. I want to subtract 2 on both sides. I can't combine these two together because this one has a radical and this one doesn't. So I just write that out front. So I get x equals negative 2 plus or minus 8 square root of 2. On number 9, I want to multiply both sides by 7. So I get x cubed equals negative 343. I want to take the cube root of both sides. I get x equals negative 7. On 10 and 11, I want to write the expression in simplest form. This means to rationalize by denominators. That means multiplying by the same thing with the opposite sign in the middle. So I'm going to multiply by the 2 minus square root of 3. Multiplying across on my numerator here is just going to give me 2 minus the square root of 3. On my denominator, I have 2 times 2, which gives me 4. 2 times the negative square root of 3 gives me negative 2 square root of 3. Square root of 3 times 2 gives me 2 square root of 3. And square root of 3 times negative square root of 3 gets me negative square root of 9. So then I want to simplify. I have 2 minus the square root of 3 over 4. The 2 square root of 3's cancel out. The square root of 9 is 3. So then I want to simplify. 2 minus square root of 3. 4 minus 3 is 1. I don't have to write that on the bottom. So my answer here is just 2 minus the square root of 3. Same idea on number 11, except this time I'm going to change it to a plus sign in the middle. Multiplying across on my numerator, 6 times 4 gets me 24. 6 times the square root of 5 is 6 square root of 5. On my bottom, 4 times 4 is 16. 4 times the square root of 5 is 4 square root of 5. Negative square root of 5 times 4 is negative 4 square root of 5. Negative square root of 5 times 5 is negative square root of 25. Simplifying, my numerator is going to stay the same for now. Then I have 16 on the bottom. 4 square root of 5 minus 4 square root of 5 cancels out. Square root of 25 is 5. So then I have 24 plus 6 square root of 5 over 11. 11 is prime, so I can't simplify this anymore. These ones, I want to use properties of radicals to simplify the expression. On the first one, I'm going to multiply my insides. So 3 times 75 is 225. I want to find my square root here, so I'm going to factor tree. 225 divided by 5 is 45. Divided by 5 is 5. 9. So, on this one, I have a pair of 5s and I have a pair of 3s. 3 times 5 is 15 for my final answer. Nothing left in the radicals, because there's nothing I didn't circle at the end of a branch. On 13, I want to do 12 times 8, which is 96. And I want my fourth root here. I'm going to factor tree my 96. So I can see it's even. That's going to give me 2 and 48, 2 and 12, 2 and 6, 2 and 3. So I can take out a group of 4 2s, and then I have that 3 left over. On number 14, I want to rewrite this as one giant radical to see if I can simplify. So I have 5 over 80. Both of those numbers are divisible by 5. So I have 1 over 16. I can split this back into 2 separate fractions. I have the square root of 1 over the square root of 16. Square root of 1 is 1. Square root of 16 is 4. On number 4, I want to simplify this radical. I'm going to factor tree 18. It gives me 2 and 9, 3 and 3. I have a group of 3's I can take out. So I have 4 times 3 with a leftover 2 in the radical. And then the minus 15 square root of 2 stays the same. 4 times 3 is 12. So I have 12 square root of 2 minus 15 square root of 2. 12 minus 15 is negative 3. And then the square root of 2 part stays alone. Same thing on 16. I want to factor tree my 63. I can see it's divisible by 3, which gives me 21, 3 and 7. So I can pull out a pair of 3's. I have 8 square root of 7 plus 12 times 3 square root of 7. 8 square root of 7 stays alone. 12 times 3 is 36. 8 plus 36 is 44. On 17, I want to simplify if possible. I have 81 that I want to factor tree. Which gives me 3 and 27, 3 and 9, 3 and 3. So I can take out a 3. So I'm going to have 3 cube root of, I have a leftover 3, c squared. Same idea for 2187. I'm going to do it over here. This one is a bit trickier. I'm going to check if it's divisible by 3. It is. So it gives me 729, which is divisible by 3. I get 243, which is 3 and 81, 9 and 9, and 3 and 3. So I'm looking for groups of 3. I have one group of 3, 2 groups of 3, and a leftover 3. So 3 times 3 gives me a 9 on the outside. And then on the inside, I have a 3c squared. So then I'm adding 3 to 9, which gives me 12 cube root 3c squared. Still simplifying here. On number 18, I can either distribute my exponent first, or I can simplify the two stuff. I'm going to rewrite it as 56 divided by 7 to the 1/4, and then this whole thing is squared, which 56 divided by 7 is 8, and then 1/2 times 2, or 1/4 times 2 is 1/2. So really I want 1/2 of 8, which is the square root of 8. If I factor tree 8, it turns into 2 and 4, which is 2 and 2. I can take out a pair of 2's, and that leaves me with the square root of 2 square root of 2. On number 19, I'm going to factor tree 7776. I can see this one's even. So that gives me 3,888. Gives me 1944. I know that one's even. 972. 36. 24. 3. 3 and 81. 9 and 9. And then a bunch of 3's. Okay, so I'm looking for groups of 4. So I have a group of 4 3's and 4 2's. So 2 times 3 gets me 6 on the outside. Then I want to move to my exponents. For b to the 14th, I can take out 12 of those, which is going to give me 3. And then I can't take out anything for my c. So I had leftover on the inside. I have a 2 times 3, which is 6. I had 2 leftover b's, and the c's I couldn't move at all. Same idea on 20. 128 factor trees into 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. That's all I have to do. There you go. I wanted a group of 6, so there's 6 right there. So I can pull out that. Inside my radical, I still have 1, 2. For my b's, I can take out 12, which turns into b squared on the outside. And I'm left with 2 on the inside, and 2 c's on the inside there. On my denominator, I can take exactly 3 groups of 6 out for my m's. Okay, 21 says a cone is filled with a liquid. The formula for the radius of the cone in terms of its volume is r equals the square root of 3v over pi h. Find the radius of the cone if the volume is 210 units and the height is 5 units. Round your answer to hundredths. So I'm just plugging in here. I have 3 times 210 divided by pi times 5. So I just want to type into my calculator. I have second square root of 3 times 210 divided by, in parentheses, pi times 5. Hundredths is 2 decimal places, so 6.33. Well, what was I measuring in units? What is the height of the cone if the volume is 65.97.3 units and the radius is 3? So I'm going to plug in what I know. So, in order to solve this, I first want to get rid of my square root. I am going to square both sides. I get 9 equals 3 times the 65.973 over pi h. I want to get h out of the denominator, so I'm going to multiply both sides by h. That gets me 9h equals 3 times the 65.973 over pi. I want to get h alone, so I'm going to divide both sides by 9. That gets me h equals 3 times the 65.973 over 9 pi. And then I just type this into the calculator. So 3 times 65.973 divided by 9 pi. Gets me 6.99 repeating. So that's going to actually round up to 7 for my height. Well, I can't really see because, yeah. Okay. These ones want me to describe the function transformation represented by of f represented by g. So on this one, it is shifting right 1, up 4. I'm going to graph f of x in blue, and then my transformation is going to be in red, so right 1, up 4. Same idea for 23. I have a vertical stretch of 3. And then I'm going left 2. So I'm going to start by drawing my f of x in blue, and then my g of x in red. So left 2 starts here, and then vertical stretch makes it go higher.